Yes, friends, welcome back to Pyramid School. Today we are continuing with our first topic, that's Algebra 1, and we are going to look into solving quadratic equations. In the previous video, we looked at factorizing or factorization, whereby we were trying to factorize algebraic expressions, especially the quadratic equations. That by that I mean of degree 2. So today we are going to look at this other sub sections that we have under solving quadratic equations. And the first thing is going to be using factorizing or by factorization. That's one of the methods by which you can solve a quadratic equation. So since we looked at factorization in the previous video, it will be easier for us to handle this. Even in the previous videos, I remember covering something to do with that. And by the way, if you're new to the channel, I would appreciate so much if you subscribe to the channel Pure Math School to support and also to follow more content. Don't forget to turn on that notification bell so that you'll be informed every time I make new uploads. Don't forget to like the video and maybe share with a friend. I'll be so grateful. And thank you to those all those who have subscribed to the channel and or following. I'm so grateful. You mean a lot to us by doing that. So let's start straight away with what you're going to do today. So as I told you before, today we are going to basically handle solving quadratic equations by factorizing. So, and I already have some examples. Let me push this ahead so that you can see. Yeah, those are some of the few questions that we are going to handle today. Before we go to completing of squares, we need to first deal with this, as we already looked into factorizing. So let's start away with that question 1. So that's the first question. If you remember very well in our previous video, for those who have watched, but when you see an expression in this form, especially for this equation, this left hand side is actually a factorized form of a quadratic expression, in that if you might expand that bracket, those factors, these two factors, you will end up coming out with a quadratic equation. So for that case, remember now we have this bracket and this bracket, they are multiplying themselves to equal to 0. Under what circumstance do you realize that you can have a 0 when you multiply two numbers? Let's consider this first bracket and this other bracket as two separate numbers. Okay, so under what conditions can you get a result of 0? The conditions are here. You can only get a 0 if both these two brackets give you if x minus 5 equals to 0 and if x plus 2 equals to 0, or if one of them, that's, let me say, x minus 5 equals to 0 or x plus 2 equals to 0. So you get 0 if either of them I mean if either of the bracket is actually 0. So for the first case, that means we are going to assume either x minus 5 equals to 0 or x plus 2 equals to 0. Those are the only conditions when that lead us to getting a 0. So let's say this implies that x minus 5 x plus 2 equals to 0 if either, so x minus 5 into x plus 2 equals 0 if either x minus 5 equals to 0 or x plus 2 equals to 0. Okay, so those are the possible conditions by which we can get a 0 from that equation. So that means if we remove 5 from this side and take the other side, I mean making x a subject, would end up with x equals to 5. Then here making x the subject also, you'll have x equals to negative 2. So those are the solutions for that number 1, that's that first part, which was actually A, since I'm using letters to enumerate them. So let's go to the next number, that's this B, x squared minus 4x minus 5 equals to 0. So as you can observe that for that first number, we had already factorized a quadratic expression. So we only had to use the factors that they had got to get the solution to the equation. Okay, so let's go to the next one, that's B. So the B is saying that x squared minus 4x minus 5 equals to 0. So you can see that this is a quadratic expression which has not been factorized, so it's upon us to factorize. And if you recall my previous videos, I said that if you have one of the coefficient of the x squared is 1, we have the coefficient of x which is negative 4, and we have the constant term which is negative 5. And we realize that we can know all the parts of a quadratic equation. A quadratic equation has the coefficient of 1. If the coefficient of x squared is 1, our product will actually be the constant term. Or basically, always you have to get the product of the quadratic equation. You always have to multiply the coefficient of the x squared term with the constant term to give you the product. But since it's 1 this time, we're going to have only the product being negative 5. And how about the sum? The sum is always the coefficient of x, and you take it with a sign or the operation in front of it, which is a negative for this case. So we're going to explore that. We go back to the product and explore the factors of 5. Let's first ignore the negative. The negative will come later as we're trying to play around to get which combination to use best. So we're going to look for the factors of 5, of which is only 1 and 5. Because if you it's only 1 that can divide 5. It's a prime number, it can only divide itself, and that's all we can have. So 5 can only divide itself to give you 1. So that means the factors are basically 1 and itself, since they're prime number. So since we have 1 and 5, we are going to look at we have only 2 of them, which is very easy for us. We will not touch so much, unlike others. When you come to that number D, it will be a bit hard for us, because we will have very many options to look for in order to combine to get the right numbers that if you add will give the sum, and if you multiply will give the product. So we have 1 and 5. Now we need to consider the sign. So in that we play with either putting negative or in both, or in only one, or we'll just let it be the way it is, just to help us combine in order to end up with when we use those two factors, we add them, we need to get a negative 4, and we multiply, we need to get a negative 5. So let me say if I put a negative on 1, we use negative 1 and 5. You see, if we add, we are going to get positive 4, which there cannot come. So let's use 1 and negative 5. Let's put negative on 5 this time, so that when we add, we are going to have negative 4. If we multiply 1 and negative 5, we're going to end up with negative 5. So 1 and negative 5 is the best combination that we can actually use for this case. So we're going to have 1 and negative 5 to use. Now this 1 and negative 5 will be the factors that we are going to use to substitute for that for whatever we will have to in that. Let's go to the next page so that I can have a clear vision of it. So here we had here x squared minus 4x minus 5 equals to 0. So we had already got our factors to be 1 and negative 5, the ones we're going to use. So that means we're going to have actually 4 can be replaced by, so we're going to have that equation being rewritten as x squared minus 1, minus let me say plus 1, because 1 is positive this time, x, then minus 5x, okay, minus 5 equals to 0. In other words, we're going to have x squared plus x minus 5x minus 5 equals to 0. In that you can see that x minus 5x will go back to negative 4x. Then this product will just leave it the way it is. Then we pair them like we did in the previous video. we factorize out the common term, which is going to be x, which will, when you factorize x from here, remain x plus 1. When you factorize 95 from here, as you can see in this second pair, we're going to have 95, which is common. We factorize it out, we still remain with x plus 1 inside, equals to 0. Then we remain with a common one, which is x plus 1, factorize it out, then remain with x here, then 95 here, equals to 0. Now we reach to the other stage that we had in the first example. That means either x plus 1 equals to 0 or x minus 5 equals to 0, whereby here we'll end up with x equals to 91 and here x equals to 5. So that would be the solution to that quadratic expression. Let's shift to the next one, which is C. C is actually saying that two x squared minus 32 equals to 0. The first thing we're going to do there, we're going to realize that 2 is common. We have, first of all, remember that that's a quadratic expression whereby the x term is not there. I mean the linear term, that's x as a coefficient of 0. That's why you can't see it there. We have only the x squared term and the constant term, but we realize that 2 is actually common. 2 in 2x squared, and there's also 2 in 32. Whereby if you factorize that 2 out, we are going to end up with x squared minus 16 equals to 0. Okay, I mean in the previous video we covered what we call difference of two squares, and you can see the concept coming here. Since 16 is a square term, is a square, you can have x squared minus 4 squared in place of 16 equals to 0. So that means you would actually end up with x plus 4 into x minus 4. Okay, that is it. That's when you remember difference of two squares, we have any expression in the form a squared minus b squared can be written in the form a plus b into a minus b. Okay, that's it. So that means we are going to have here since 2 was actually a constant term, it will just vanish, since if we divide both sides by the constant term, that's 2, it will just be 0. Divide throughout by 2 to just be 0. So that we are going to remain x plus 4 into x minus 4 equals to 0. Okay, that means either x plus 4 equals to 0 or x minus 4 equals to 0. What does it mean? X is either negative 4 or x is positive 4. That will be the solution for that number. See, there we have applied the difference of two squares, which we looked at in the previous video as well. And then let's go to the final number, that's D. You can see here D was talking about 12x squared plus 17x minus 14. Now this one is a bit more complex compared to what we have been doing before, and I think it's a high time we handled it. So we have here D is saying that 12x squared plus 17x minus 14 is 0. So the first task we are going to do is to get the sum and get the product. The sum is always the coefficient of the x, which for this case is 17. The product is always coefficient of the x squared term times or multiplied by the constant term. For this case, product is going to be 12 times negative 14. Since you see that is negative 14 here, and the coefficient of x squared is what, 12, which will give us, I think, negative 168. Let's try to prove that from the calculator. 12 times 14, yeah, 168. but there is a negative on 14, so that's why I put negative 168. So now we have the product, which is a negative 168. So let's explore 168. Let's try to get its factors. Divide by 2, we're going to have 84. Divided by 2, we're going to have 42. Divide by 2, you're going to have something like 21. Divide by 2, we're going to have 21 cannot be divided by 2, so it's going to be divided by 3, which is 7. Then by 7 you end up with 1. 7 is a prime number, so it cannot divide itself and 1 with 1. So the factors that we have, factors of 168, actually 2, 2, 2, then we had 3 following, then 7. Now when we have factors which are very many like this, it's so confusing because you need to look and search for the perfect combination that will bring about your sum and your product. And we also need to consider the signs later. If you can realize that if you try to combine 3 and 7, let's say we are always going to use the operation of multiplication to group them. That means I can decide to multiply 7 and 3 to give 21. Then I group with 2 times 2 times 2, which could be 8. 21 and 8. For this case, 21 and 8, if we put negative on any, let me say we want here positive 17. Yeah, let's put negative on the smaller positive value. When we add, we are going to end up with only 13, which is not 17. That means that combination cannot actually come. What if we group those ones and leave 7 alone? Okay, let's say it's 2 times 2 times 2 times 3. What is that? I think it's 24, because 2 times 2 is 4 times 2, 8 times 3, 24. Then 7. So that means we try to group 24 and 7 to see which can it bring about what we want. We see here that we have, when we put negative on 7 and we add to that 24, 24 minus 7 will end up with 17. That's for sum. Then if we multiply 24 by negative 7, what will we end up with? 24 times 7, I mean negative 7. 24 times negative 7 will be negative 168. So you can realize that 24 and negative 7 is a perfect combination that can bring about our sum and product. So that means that this bulky expression 12x squared plus 17x minus 14 equals to 0 will now become 12x squared plus 24x minus 7x minus 14, giving us 0. Okay, so that we can now pair. We have here first pair, we have 12, which is common, 12x actually. 12x is in 12x squared, and 12x is also in 24x. Okay, so we have 12x, a common term, remaining here with x. Okay, then plus 12x removed from here will remain only 2, because 2 times 12x will go back to 24x. Then we can see that the second pair we're going to have negative 7x minus 14, and you realize that negative 7 is in both. That's why I factorize out negative 7. Here will remain with x. Then since negative 7 has been removed from this negative 14, negative 7 has been removed from negative 14, that means we are going to remain with still positive 2 here, so that when you multiply 2 and negative 7, you go back to negative 14. Then the whole of that will be equal to 0. Okay, now what next? We are going to see the common term here, which is x plus 2. X plus 2 into 12x, since when you remove x plus 2 here, you remain 12x, minus 7. Because if you remove x plus 2 from here, you'll end up with negative 7, giving us 0. So I think we have come to the easier part now, that now we have either x plus 2 equals to 0, okay, or 12x minus 7 equals to 0. Here we're going to end up with x equals to negative 2. Then here we're going to end up with, you see 12x minus 7 12x minus 7 equals to 0. Make 12x a subject. You end up with 7, the other side positive. Now then it's going to be x 7 out of 12. So you end up with x equals to 7 out of 12. Okay, that's what I've been doing. So we had to make x a subject from that, so that I came out with that. So that's all for today. I think we are done with that factorization part of solving quadratic expressions, and our next target will be this completing of squares. Okay, you can see that it's going to be this completing of squares. For today we are done with this, and please thank you so much for coming to the channel. I would love to see you back again, and don't forget to please like the video in case you enjoyed it. Don't forget to subscribe, don't forget to turn on that bell so that you'll be informed every time I make uploads. See you in my next video.